Live up to that introduction. So it sounds like everybody here is really experienced and has been homebrewing for a while and knows a thing or two about how to know. I'm going to know so what I'm going to talk about is kind of QA and QC for homebrewing. This is kind of a top 5 or 6 or 7 things that we at NoDa Brewing identify as like they're kind of the top things that we pay attention to and test for and constantly test for. And it's stuff that you guys can test for too. It's most of it's really simple. Yes, we have some very expensive gadgets that allow us to quantify things and get cold hard data to track trends and that kind of stuff, which I will talk about that at the end about note taking. No matter how you're tracking this stuff, I can't emphasize this enough, write everything down, even no matter how silly you think it might be, because you'll see trends over time. And when you can see a trend, we try to do things based on data and not on anecdotal evidence. We try not to do, well, it worked last time, so let's try it again. Hey, it worked again, let's try it again. That's, might work, kinda, but we really want to have data to back it up. But anyway, I'm kind of getting off track. So my point, real point is that some of you might already be doing some of these techniques. If you're not, start doing it. If you are, great. So he's right. I started homebrewing maybe 15 years ago. I haven't homebrewed in like 4 years. So some of the techniques I talk about might be outdated, or you might know a better way of doing it. If you do, come and tell me, because I'm not saying I'm never going to homebrew again, but there might be a better way of doing something. Let me know. I mean, I know how we do it at the brewery at NoDa, but homebrewing is a different animal. You guys know that. Anyway, so one of the things I'm going to start off with talking about is diacetyl. I'm kind of pick up where Chad left off. He talked a little bit about hop creep. We're going to talk about that in a while. That's something that's been a lot of folks in the industry have been talking about for a few years now, but it's really something that just kind of people started to figure out. But I'll bore you with a little bit of the science behind diacetyl. So it's vinyl diketones are kind of precursors to diacetyl. There's 2,3-butane-dione and 2,3-pentane-dione. The butane-dione is the diacetyl, that's the buttery note, that's the thing that really makes your beer taste awful. And pentane-dione are honey notes. So you've really got to be kind of good to pick up on those. But and sometimes you'll go, ooh, I like that honey note. Anyway, diacetyl can also be caused by bacterial contamination, but more often than not, it's caused by the yeast. And it's a perfectly normal part of fermentation. Happens with every fermentation. You just have to, let the beer clean it up, or let the yeast clean it up rather. The detection threshold is very style dependent. It's 0.1 part per million. And again, we kind of quantify that in the lab. We have an actual number that we write down, so I make sure that the beer is clean. But you can detect it. Most people can detect it just by doing a simple test, which I'll talk about in a second. Fun fact, and I just learned this in kind of putting this slide together. I never knew this, but Garrett Oliver wrote that 25% of the population cannot detect diacetyl. So if you can't get it in your beer, or if somebody says, dude, this is a diacetyl bomb, but you're like, oh, heck, it's don't feel bad. I mean, my predecessor at the lab was completely blind. He couldn't smell it, he couldn't taste it. He could kind of try to guess based on the mouthfeel, like that slick mouthfeel that you get. But for the most part, he had no idea if a beer had diacetyl in it. So don't feel bad if you can't get it. You're one of 4. Just find a friend and go, hey, is this ready? So just, I'm going to give this out too. I'll make a PDF that'll be available to you guys so you can look at this a little more. So basically, sugar comes in, the yeast will create a compound, alpha acetolactate, and that's used in amino acid synthesis. There is an excess of that, and that will kind of leach out of the yeast cell, and then in the presence of oxygen and a little bit of age or temperature, that will create diacetyl, right? And so that's what we don't want. Over time, though, healthy yeast will reabsorb that diacetyl, and they'll turn it into 2,3-butane-diol, which is nothing. Nobody, flavorless, it's odorless, it's harmless, right? So it's not going to kill your beer. But that's a real quick overview of how diacetyl is formed. Diacetyl rest is very important. Everybody talks about, how long should I rest my beer? It depends on the beer. We'll talk about Hop Creek in a second. We typically, at 60% attenuation, will let the beer do a free rise. So how many people are doing fermentation, like a temperature control fermentation? All right, cool. Pretty good size. So if you're controlling that temperature around whatever you're fermenting at, say 68 degrees, at about 60% attenuation, let it go ahead and rise. And that'll help. It'll speed up your cleanup a lot. If we forget to turn up a beer, which doesn't happen, then like, okay, great. I guess we're going to wait another week for it to clean up. If you're not doing that, then just when you hit terminal gravity, just let it rest for a couple of days. And I think, yes, forced diacetyl test. If you're really concerned about this, do a forced diacetyl test. It is super simple to do. Just take a sample of beer, heat it up to 150 degrees, and hold it there. This is this is a sous vide that I bought on Amazon for $50. If you have one, it makes the best steak on the planet. So, True. That inch and a half thick ribeye, finish it on a prop skillet. Anyway, it also works great for forced diacetyl test. That's what I've got here. You guys can see in the little bottles, media bottles in there. It's 200 mils of beer. I put it in there, hold it at 65 C or 150 degrees for about an hour, and then cool it off and drink it. And if you can taste diacetyl or smell diacetyl, or you get a slick mouth feel, the beer's not ready. So let it sit for another couple of days or a day. We had one clear up today that a lot quicker than I thought it would. But yeah, it's that simple. There are commercial breweries that are not doing this. It's scary. Yes.
What's the sample size that we would want for that?
Any sample size. I know you guys are probably doing 5 gallons, 10 gallons kind of thing, so you don't want to necessarily start pulling 200 mils every single time, right? But just enough to sample. Yeah. So whatever, 50 mils will probably 25, 30 will be plenty. Okay, so Hop Creek. I don't know if you guys know about this or if you've heard about this. Like I said, the industry is starting to talk about it a lot more and identify it. It's something we deal with at the brewery. We are doing some adjustments to help mitigate that. But basically, hops have a diastatic capability. And yes, diastatic is the same as diastaticus, if everybody's heard about the evil yeast out there, the SD1 positive yeast. Basically what it does is the hops will break down, when you dry hop a beer, the hops will break down dextrins and other unfermentable sugars into fermentable sugars. And the yeast, the residual yeast that's still in the beer, is going to go, ooh, food. So it eats it, it's going to cause a re-fermentation. And it's going to create more alcohol, it's also going to create more diacetyl. So if you've ever had an IPA that you thought was done, and then you dry hopped it, and then you racked it and kegged it, and then you got diacetyl, that's why, more than likely, that hop creep happened. I'll show you a graph in a second that shows you kind of how our beer, any beer, will hit terminal, we'll dry hop it, and then a couple of days it'll just ride. It'll stay at that same terminal gravity. And we look at it and go, well, it's done, or you would think it is, but no, give it a day and then you'll see it start to creep down. And I'm talking like 1/10 of a Play-Doh a day, kind of a thing. And then you just kind of have to wait, and we kind of know now, when our beers are done. Then give them a couple of days, run a VDK test, it's good to go. So, terminal gravity, quote, terminal gravity versus terminal gravity, right here, perfect. So this is an IPA, started out at 16 Play-Doh, and you can see here where we dry hopped just before it hit terminal, because what we want to try to do is to get as much, benefit from the dry hop, as much aromatic punch and everything that we get from a dry hop, but at the same time kind of have that diastatic thing happen while the primary fermentation is still happening, if that makes any sense. So, and I've got a link to an article that is going to blow your minds at the end of this, that we just read, and we've been running some experiments about when we're dry hopping. Anyway, you can see kind of right here, and this is the gravities. So 4 and 5, we dry hopped on day 3, 3.8. Went to 3.6, 2 days of 3.6. You think it's done. Nope, 3.5, 3.2, 3, and 3. And that's when it was done. And we knew it was done at that point. And that's the hop creep. Now, the downside to this is that your beer is sitting on the hops this entire time, right? And you don't want that necessarily because it's going to get a grassy note and all that kind of thing. So, yeah. Anyway, on to ways to mitigate hop creep. As I said before, we are doing, we're dry hopping mid to late fermentation. That helps. But this is something that we've been experimenting with, and we just read an article in Brewbound, and I've got a link for it in here so you can go check it out. That dry hopping after VDK cleanup. So let it go all the way down, finish, clean up VDK, lower the temp to 55, and this article actually kind of says lower it to 34 to 39, so almost crashing the beer, and get all that yeast out. So we'll do that, we'll dump the cone, then dry hop. And then after 2 days, then we'll crash it all the way, or you guys will move it to a secondary vessel. So, and it works. It works great. Also, this article talks about aroma extraction is optimal at 2 days. Past 2 days, the aroma compounds will go back into the hops and add a solution. Kind of weird, but apparently true. But the main thing to remember is if you think it's done, let it rest. Particularly with IPAs. Again, we have some of our beer, our blonde ale Kabu. I swear it cleans up like while we're knocking it out. I mean, it cleans up really, really fast. But hop, drop, and roll just takes a while. So just give it time and test. Again, if you have the volume to test every couple of days, do that. It'll really, really help you out. Any questions on that? No? Here's the reason. So again, these are other QA/QC methods. They're probably things you guys are already doing. If you're not, look into them. It sounds like some of the people here can help you out, or Google, YouTube. Who's doing yeast starters? Anyone? Yes? Most people? Yes. Thank you for doing yeast starters. And I just threw up some real quick math here. So for a 5-gallon batch 1048, you need 228 billion cells. A White Labs homebrew vial contains 75 to 150 billion cells. That's not enough. Will it make beer? Yes. Will it stress your beer out? Probably. Will it stress it out to the point where it makes a bad batch? No. But, you just want, you don't want to go nuts with overpitching, but at the same time, you want enough in there. So just do a starter. We do start every batch of a beer that we do over at OG starts out with a 3-liter starter with 2 homebrew vials, or 4 if it's a lager, or more if it's a bigger beer. Which I'll talk about in a second here. But 1.5 liter starter will give you 240 billion cells, give or take. That's more than enough for your 5-gallon batch. Obviously, double it if you're doing a 10-gallon, or triple it, doing a 15-gallon. You do you. But the target pitch rate is 1 million cells per milliliter per degree Plato. I pulled that from, that's kind of common knowledge these days. I pulled it from Chris White's yeast book. If you haven't read that, you need to get a copy of it. It's great. Everything you ever want to know about yeast is in there. So we'll do, I think I put it in here. Yes, I did. So that's our target pitch rate for most of our beers. For instance, Jam Session starts off with 12 Plato, right? So that's kind of a down the middle pale ale. So we shoot for that 1 million cells per milliliter per degree Plato. For Hop Drop, it's a little higher, starts a little higher, so we want 1.5 million cells. I kind of have a multiplier built into my little spreadsheet that will tell me how much yeast I need to give to a certain beer, depending on that. We'll do 2 million cells for like 20, if we're doing something just huge, a 1085, right? Something, your red that you were talking about. You probably overpitched the stuff out of it. No? Ooh, okay, well.
We'll see how it's going.
I'm sure it's fine.
It hadn't gone down the drain yet.
You're winning. Yeah. And also lagers. Overpitch your lagers. Double your pitch rate for your lagers. I don't know. Lager yeast just needs more yeast. I've put in a quick recipe for you, those who aren't doing yeast starters. The 6 ounces of DME, a liter and a half of water, boil for 10 minutes, cool it, pitch it, and if you have a stir plate, great. If you don't, just kind of go by and I used to do mine in growlers, and I would just put them on top of the fridge, and every time I walk in the kitchen, I would just swirl it. Worked fine. Forced fermentation. This is something if you're that you can do if you are worried about diacetyl cleanup, that kind of thing. You want to know where your beer is going to finish before it gets there. Pull a little bit of wort out. When you're knocking out, pull a little bit of wort out. Pitch a little yeast in it, and if you have a sous vide, we use that for all kinds of stuff there. Hold it at 80 degrees. You'll see about 50% attenuation in 24 hours. If you put it on a stir plate, you can't agitate it. This is when you really kind of do need a stir plate just to keep it going. And then within 48 to 72 hours, it will hit terminal gravity. So it really gives you an idea ahead of time where your beer is going to finish. When we're doing experimental beers, or when we're doing something that we haven't done, like with hotcakes that we just did, we ran a force ferm on it just to see where it's going to finish. So we know, we can anticipate when we're going to dry hop, we can anticipate when it's going to clean up, we can anticipate these kind of things. So it's a cool thing, man. You can see where your beer is going to finish before it gets there. Oxidation is a big thing with us too, particularly when we're talking about shelf stability. I just threw some numbers in here of what we worry about. Obviously, you guys can't necessarily measure to the parts per billion. We have lots of little gadgets that will do that, but this is just for reference if you're curious. If you're not doing this, purge your kegs with CO2, please. It's you'll run through some CO2, but man, it really helps with oxidized beer down the line. Another method that a buddy of mine used to do, he would fill it with star sand and then fill the headspace with CO2. Purge that a few times. Sorry, who did that? Sammy?
No,
Were you my buddy that did that?
I drank Star Sand.
You drink star sand? Yeah. Who doesn't?
Long story.
Oh, I get it. So, does it carb? Can you carb it up? Like carb it? Or you just do that on nitro? That'd be a good nitro. Star sand nitro, yeah. Nice.
That's carb sand. That's
Nice.
He does the Star Sand
Nice premium
seltzer.
outfit.
Like a little raspberry.
Yeah. Don't fear the foam. Yeah, anyway, so fill the keg with star sand, take it over sand pails and drink it up. Fill headspace, purge it 4 or 5 times, and then just push the star sand out. Double duty, you've also just sanitized your keg. So, yeah, that's a big deal. Transferring beer to a keg, go slowly. And again, I'm sorry, if you guys are doing this, then some of this is kind of elementary, and I understand that.
Go with it.
All right. Transfer gently, don't splash. If you're doing the gravity feed thing, if you're doing, the auto siphon, on the table. If not, look into rigging up a closed system and push your beer in with CO2. That's kind of how we do it at the brewery, right? I explain when I give tours at the brewery all the time. It's shocking how many things that we do that are so similar to what we did in homebrewing world, right? It's just a bigger scale, and we use pumps and we use things like that. But as far as pushing, when we're centrifuging beer from the fermenter into the bright tank, we're keeping a constant head pressure on that. We're doing this. We're pushing the beer over gently as possible. So. I put coned up in parentheses or in quotes here because some of you guys might be using conical fermenters, and if you are, that's great, and you can do cone dumps, do that. If you're not going to package your beer immediately, rack it off of your yeast and your hops. And if you have the ability to cold crash it, and then rack it off, because autolysis is, when your yeast starts to eat each other, that will really create some weird flavors, acetaldehyde, all kinds of crazy stuff. And grassy flavors from hops. Those grassy notes, when your hops start to roll off, they'll get a little grassy. Not good. So if you're not using a conical, you're not really doing a cone dump. You're just moving the beer off of it's a beer dump. That's not right. Yeah. And I would be remiss if I didn't mention bacterial contamination. And really just to emphasize, clean, some more, sanitize. If you want to get nerdy about it, you can. There is a relatively inexpensive method to test for lacto and pedio. It's called HLP, Sue's Lactobacillus pediococcus medium. It's pretty easy to prepare. You'll get results in 48 to 72 hours. So if you are having a contamination issue, you can kind of test at each stage, right? Pull a sample at knockout, pull a sample of your work, pull a sample post-fermentation, and then you can see if you get development post-fermentation, then you know it's probably in your carboy, that kind of thing. If you want to know how to do that, see me after, and I'll let you know. It's again, it's relatively expensive. It's super easy to prepare, but it is a little dangerous. It has cyclohexamide in it, which inhibits protein synthesis in eukaryotes, and everybody in here is a eukaryote, so don't you have to eat like 500 milligrams of it. It's not that super dangerous, but at the same time you don't want to breathe it. So anyway, see me, wear a mask, it's fine. I'll be fine. But yeah, that's the first test I run. Every time beer moves, I run this test on our beer. We have some other cool stuff that'll give me answers faster, but this is a surefire way to let us know if we've got a contamination somewhere. Way we don't have right now. Note taking, it's serious business. I mentioned it earlier. I'm going to just mention it again. There's no magic thing I can tell you about note taking. Everybody takes notes differently. Just do it. It will absolutely. If you're going to be brewing a lot and you're trying to compete, and you're trying to win medals, that kind of thing, write everything down. I mean, if something weird happened, if you missed your mash temp, if something weird happened in the transfer, make a note of it, and then you can go back and say, oh well, I didn't hit my terminal or whatever, it was high or low or whatever. Then it's because of my mash temp or it's because of something happened. So. And I think Mark said I was going to tell you the magic of note taking. There is no. Just do it. I know it sounds.
That's magical.
Yeah.
Damn it, Mark.
So I wrote some resources here. Two really cool things here is one, that Brewbound article I was telling you about the reevaluating dry hopping techniques. Look into that. It's a fascinating read. And in all of our research on hop creep, I found an article from 1893 that was writing about the dry hopping beers and how it affected the final gravity. It's 1893, so it's apparently nothing new. But this article or this paper got buried a long time ago.
Apparently.
Yeah. And there's also one from 1941, the diastatic activity of hops. So these are older things. You can Google stuff and find other more current papers. But I just thought if you're a history buff or if you're into that kind of thing, you could get a kick out of those. So that's it. Questions? Anyone? Yes.
I got a question. So if you have diacetyl and a beer that you already kegged, what are your options at that point?
Yeah,
Snifter or pipe glass?
Distill it.
Yeah.
Give it to your friends and don't send it.
Give
Give
it to
one
your
of four friends.
Too soon?
So, forced fermentation, that was interesting.
Yes.
When you do that, how do you extrapolate? So if you're doing that in 24 to 48 hours, how do you know on day 5 that's the right day to dry hop?
Well, it depends on when we're going to dry hop. I hope I'm about to answer your question. It depends on if we know we're going to dry hop at terminal, if we know we're going to dry hop a day. We take gravities every day. I know that when I was homebrewing, I didn't take gravities every day. But I don't know how often you guys do it. If you just like throw it in the closet and forget it, that's cool too. But I'm not sure if that's answering your question.
No, so for hop drop, it looked like you guys dry hop a few days before terminal.
Correct. Well, it was actually kind of the day. Hang on, let me find this. Here we go. So it's kind of the day before it hits terminal. Is or as it's coming into the terminal.
So with your forced fermentation, how do you know what day that is?
Well, you won't know what day it's going to be. You just know what it's going to be. So if you're measuring the gravity often enough, you can see, well, it's here now, so it'll probably be there tomorrow. You know, and it's, again, we're only doing it once a day. There are some cool stuff that everybody's trying to sell me that'll take a measurement every minute. Which would be great, because then you would be able to tell, probably, you know, predictive analytics and all, I'd be able to tell like what day it's gonna hit that. So it's a lot of it's got to do with pitch rate. You know how much yeast you put in there. If you overpitch, it's gonna get there quicker. You know, so if you're hitting your pitch rate right, you know, it'll take, I don't know, 4 days, 5. You know, it depends on the beer. I think it depends on the original gravity. It depends on a lot of things.
Do you yeast nutrient? Yes, no?
Yes. Yeah. Yeast X.
And that's so with getting consistent beers, I assume that you're doing the same process every time, and then you'll know your hop drop on day X.
It's very predictable.
It's time to put the stuff in.
Yeah. Yeah. It's pretty predictable. You know, I would say that hop drop like this hits on day 3 or 4 is terminal. Probably 3, you know, midnight on day 3 kind of thing is when it hits terminal. And it's pretty predictable. You know, we make the same wort every time. We put the same amount of yeast in there every time, so it's for the most part pretty predictable. But if it's a new beer that you're brewing, that's just it. It's not that we're necessarily going to be able to predict when it's going to hit it, but we know what it will be when it hits. You know what I mean? So we'll be able to kind of know, like, well, if forced ferment got us down to 2 Plato and we're at 3 today, it's probably going to be there tomorrow.
Going off of that, would it be a better way to think about this? Going off of that, would it be a better way to think about this as, okay, I know where I started, and with forced firm, I know where I should finish, so if I want to dry hop, you know, right before it, I need to be doing it at about 80, 85, 90% attenuation, because then you can actually theoretically calculate out the number based on the assumption that gravity is going to be somewhat linear.
Yes, exactly. That's exactly right. I mean, most fermentations will kind of, like, you see this, it kind of ramps out of it. You know, it's a pretty quick fall on day 1 and 2, and maybe day 3, and then it kind of slowly ramps into terminal. But yeah, that's the point, is that if you know you want to try to dry hop, like our hazy, I know Chad talked a lot about our hazy, we dry hop the day after knockout, so who cares where it finishes, you know, in regards to dry hopping. I mean, obviously you care in regards to ABV because, you know, laws, but yeah, if we know that it's going to finish at, like, if we knew, like I said, if we know that it's going to finish at 3.6 and we want to dry hop the day before that, then at least we'll know it's going to finish at 3.6 and we'll be able to kind of predict when it's going to hit that. Did I answer your question? Right?
Yeah, that was good.
His question answered.
His questions answered my question.
Okay, cool.
No, I typically don't do secondary. We were talking about the conical, removing it. Are you talking about right before you cold crash it, get it off the yeast? And the dry hops that are in there, or?
Honestly, after, you know, so in the, think of it in cone dumps, we do cone dumps the day after knockout, which just gets rid of the true and the proteins in there. We do it the day it hits terminal gravity, and then we do it the day, 2 or 3 days after crashing. Because once all of that yeast falls out, you know, we'll do a cone dump. We'll get as much of the yeast off as possible. Sometimes our beer will sit in the fermenter for a while, a week, and we just don't want it to be sitting on the yeast or on the hops for that amount of time. That's kind of the reason. So it's, I guess in this slide, I was referring to after crashing it. Yeah. Or at terminal even. If you know it's done and it's cleaned up BDK and it's done, go ahead and get it off the yeast. There's no point in, you know, so if you can't cold crash, like I know not everybody's hammering up, but when you're not doing ferment, if you're not doing temperature control, then, you know, then you're not. You know, that's fine. And you're not cold crashing, then just pull it off. As soon as the beer's done, pull it off the yeast.
you do that consistently, you're gonna get consistently good beer, or by doing that, you prevent something weird from happening?
Yes. No, seriously, maybe it's in my head, but since we started doing regular cone dumps, which we haven't always done them, but since we started doing them, I'm noticing a more consistent product. And again, maybe it's in my head because, you know, I want it to be there. But it also is going to avoid any problems. If the yeast is stressed, if there's something wrong with the yeast, we're not going to harvest the yeast or, you know, whatever. If there's a problem with the yeast, then yeah, you know, it's going to mitigate any kind of issue like ontolysis or any kind of weird off flavor that it's going to create. It's going to help mitigate that, you know.
Because you listen to podcasts and stuff, and they say they've done tests and leaving it in the fermenter with that stuff in the bottom, there's not a lot of contact with the beer, it's fine.
Okay,
It's hard to know,
yeah.
like.
Yeah, I know, and I mean, you ask 5 different brewers, you get 6 different opinions, you know, I mean, yeah. I mean, I went to Brewing Summit a couple years ago, and they had a whole seminar on diastaticus, you know, and everybody in the business is worried about it, right? And we get up there, and the moderator comes up, and she says, I apologize, we have 5 people on the panel here, and you're gonna hear 5 completely different opinions on how to address this, how to deal with it, how to protect it, whatever. And we sat through it, sure enough, 5 completely different things. And somebody finally stood up and said, how am I supposed to deal with this? Or what am I supposed to do, you know, as a brewer? So to your point, yeah, you might hear people say that you aren't gonna get any kind of problems with that, and you might not. I think with us, it's more of a preventative thing. Yeah.
So to add on to, I think somebody else's question, they asked about diacetyl lactic tank. I've had one that tastes, it tastes like butterscotch and butter popcorn. And I just let it sit a day or 2 in room temperature, and it kind of, most of us homebrewers don't have centrifuge pumps and yeast filters and stuff like that. So is that a good thing, a bad thing to just let it sit an extra day or 2, kind of purge the headspace?
This is after you kegged it?
After it's kegged.
Yeah, no, that's a good point. You're gonna have residual yeast. Everybody has little, you know, bits of business in the bottom of their homebrew bottles, right? Because you're not necessarily filtering, you're using biofine or whatever. You're not doing that kind of stuff. So you're right, man. That yeast is still viable, and it could very well clean up, you know, whatever's going on. So, yes.
Red.
Kind of similar to what Sammy was saying, cold crash, but don't secondary. We were talking about picking up grassy notes and something that the yeast would do.
Autolysis. Yeah, they basically eat each other, and
So-
they kind of pop. And
It
they,
smells great.
this guy knows.
So, once it's crashed, how long are you willing to leave it there before you pull it off? I mean, you talked about doing the cone dump almost immediately, I think.
3 or 4 days after crash. We want to make sure everything's falling out.
You do have a
Yeah.
time frame.
Yeah, ish. I mean, it's, you know, it's not a rock solid. If our cellar guys can get to it at day 3, great. If not, it's day 4, you know. We used to not do it, you know, and we used to not have those, like kind of what he's saying, we didn't, or something you were saying, it's that we didn't have problems, you know. But this has helped. This has helped with the consistency of the product. You know what I mean?
What do you consider risky?
As far as the time, I mean, we're talking about IPA, like with it's been dry house for a couple of weeks, a week, for 2 weeks. So I mean, if you're packaging soon enough after all that's done, then you don't have to worry.
Sometimes it's Wednesday and it's not the weekend.
Oh, you're fine. Yeah. No, you're fine. You're fine. I should have qualified this. A lot of the way I thought about this was the way I homebrewed, and sometimes my beer would sit for like 2 weeks before I got to actually packaging it. So I kind of had that in mind. I know some people's schedules are weird and they can't necessarily get to it, you know. So I kind of thought about that in mind, about how we approach it, because we know, because our beer will sometimes sit in a tank for 2 weeks, you know, just because we don't have a bright tank available, you know. It's all depends on demand, and that's. over my head, pay grade wise. I don't think about those things. Just tell me where
All right.
with beer.
Last question, last question.
I want, so take it back to basics on the yeast starter comment. So if you just, can you go back a couple slides where that was? Sorry. So if you just run the numbers, some people might think, well, if I just double up, then that, like 2 vials or 2 packets or whatever, but is there any advantage to, like, if I wake out of bed tomorrow and have to run a mile, that's gonna hurt a lot worse than if I ran a mile. Well, if I don't run miles, I don't run, but if you had a warm-up, so to speak, like, is there any advantage to having a head start, like a yeast start at high poison, you pitch that, it's ready to roll, versus like either a smack pack or something like that that's just coming in cold?
You can absolutely do 2, homebrew bottles. I think is what you're kind of alluding to, right? Like just double pitch out of a homebrew bottle. That's fine. The way I kind of like to think about it is what this does is you get new cell growth this way a day in advance, right? And it's kind of like the yeast. It wakes the yeast up. They make new cells. The new cells are hungry and they've got purpose. And it's kind of, I know it sounds silly to think of it that way, but they do. When they're in a homebrew bottle, they've been sitting in the cold forever, and maybe you warmed them up with a smack pack or whatever for the day before, or the morning of, or whatever. And that's cool, and they're fine, there's nothing wrong with them, but I just think you get a healthier bunch of cells, and happier cells, and more, a higher viability, higher vitality, just, everything. You're just kind of,
He said happy little cells.
Happy little cells.
Bob Ross, yeah, happy little cells. Thank you.
Special thanks to Anthony Proctor. Give a big round of applause.